Okay, thank you for being here. We have a very important guest, all the way from Mago, LG. I would like to introduce Professor Moontae. He's also the lab leader or team leader at LG. Let me just say a little bit about him. He's an assistant professor of information and decision science at the University of Illinois in Chicago. And he is currently the director of advanced machine learning laboratory at LG AI research. He does research in large language models, and he was invited to Microsoft Research Redmond as a visiting scholar in 2019. And he has been working in this area for a long time. And he's here to share his precious experience and knowledge. I think it's wonderful to have him here. Let's welcome him with a warm applause.
Thanks for the nice introduction. I was wondering whether I should give a talk in Korean versus in English. Which would you prefer? English, I'm Korean. English. Is that in English?
Yeah. Okay.
And that's going to be another adventure because this is pleasantly the first time that I make a talk for Unlearning, especially in English. Also never really gave a seminar in Korean as well. The title is Learning to Unlearn. So our goal is to robustly and efficiently machine unlearning for large foundation models. Just as a heads up, it's not all models are really large. See our experiment. Well, let's take a look at it. And it's a work, like a collaborational work with many people, like Sungmin, Joel, Sungju, so these are really almost first author type of work and a couple of advisors together.
Okay. So whenever I try to give a talk, I reuse this slide a lot. It was a news article published by Stanford Human-Centered AI, which is a pretty famous center, and it was around 2021 February. The title was How Large Language Models Will Transform Science, Society, and AI. So it was right after GPT-3 came out, and we were able to see the amazing task adaptability in a way that ask whatever type of a task just by describing as a text, and it just do it as it wants. And today, one of the old friend, Richard Socher, uploaded a small post on the LinkedIn that, there was a couple engineers around 2019 who estimated or predict or forecast the future that every NLP task will be prompt engineering eventually. So indeed, the translation was one of the biggest NLP tasks. Typically, academic setting, we don't really study. We no longer study translation because it's pretty much beyond the problem for the academic setting. But even these LLM, we are study again this translation, and it included screenshot. It's translated French into English, things like that. So the downstream impact of the AI models are tremendous, in some sense not measurable, because in the old days, every different task we have to build or train models separately. And it never really generalized well into the other domain, and the domain adaptation was really difficult task, and how to reduce the gap between two different support of two different distributions like that. These days we are learning a foundation model whose support is very large, and this news article basically tries to say about that. 2022, especially as like industry leader, we compete a lot about the model parameter. And surprisingly, when we increased the parameter size, we were able to observe like some expected result. So the task performance increases. However, at the same time, we were able to observe immersion abilities, which basically the task performance used to be 0, but by increasing the model size, it's just suddenly able to solve. Of course, at the end of the 2023, we were able to observe that some of these immersion capabilities are byproduct of nonlinear metric designed by human or some discontinuity in the human metrics. So it's still under debating, but at least the parameter scalability has been proven, and some of the immersion capability likely many people believe. In 2023, after GPT-4 came out, and like some people tried to increase their voice on the safety issues, and this article was from the Future of Life. It's some like non-profit org that tries to call some signature. Oh, let's stop the fastest evolution of AI models for at least 6 months, so that we can get a better understanding about how these model behaves. There are a lot of like important people signature, including Yusha, Stuart, Elon, Steve, and even including Yuval, like non-AI people, but who are talking a lot about AI in the perspective of the philosopher and writers. 2024, it's hard to pick any one topic, and still it's 1 month is left. And so I just grabbed randomly, but like basically do some sort of important sampling. And like many people talked about sovereign AI, AI is related to the national power, but these bullet points means something to me, like data ownership, intellectual property, national security, and how this AI model impact to the labor market, of course, ethical, societal implications, these are all there. One interesting slide that I provide for this talk is I was asked to design this new class, AI Safety, Ethics, and Governance, and I try to pin down some of the topics, really just pick core topics that I cannot like help teaching, I cannot go ahead without teaching these topics. So it includes basic introduction, bias, fairness, trustworthiness, privacy attribution, like moderation and alignment, a lot of topics, and its related impact to the society, including economy, healthcare, policy, things like that. It turns out that there are a lot of evolving topics, and we are not the alone that interested in the impact of these models and how to use these models like that. So I'm Moontae. I'm like directing Advanced Machine Learning Lab in LGA Research, and as get introduced, I'm assistant professor as well. So today I try to like just pick one topic. I guess I have 2 different modes on like giving a talk to the people. For the general public, I try to talk more about just the high level and what would go for the future, and try to talk more about the implication. Whereas, like coming back to the university, like rather than just talking about high level stuff, try to pin down at least one topic. So today I wrote a learning topic, which was actually developed around this season. About first now, it was 2021, like November to December. I still remember the date that we designed the topic. And just before going into the detail, always caveat. So, like, if you can see these like slide, there are a lot of unclear stuff and maybe something wrong in the experimental design or even the methodological novelty. It's mostly because of my fault, but our people really tried a good job. So let's see it. Let me start with the motivation. So out of debate or the legal issues on the intellectual property, ownership of the data, copyright. from image domain, text domain, even artistic, filming, a lot of these debate. So that happened. So in the perspective of that, let me think about why unlearning would be important. Of course, there can be many different aspects. Some people just try to think about safety direction. Some people, it's just methodologically interesting because maybe it's a reverse of likelihood training. And I just picked 3 different perspectives. One is contamination, and the other 2 would be privacy and copyright. While today's talk are more focused on these 2, like a second and third aspect, while I was struggling a lot with the contamination, as in the industry, we need to release the foundation model on a regular basis and always compete with other foundation model and on the benchmark test. And we are all like building new method that improve the benchmark test, whereas measuring how much the model is contaminated on the test set becomes very complicated. So whenever we got some sort of a contamination on the test set, we cannot really retrain the model from the scratch because of these prohibitively large expense. So how to actually remove those training data set to get fairly measured and to fairly prove the generalization capability. That's very important for my daily perspective. But at the same time, as a company, we have to preserve the privacy. Whenever there's sensitive information get leaked, we need to erase those information without forgetting too much about the model. And the copyright, because we train a lot of data, that's always important. And there was one article, 2023, OpenAI talked to the UK Parliament that, it's impossible to train a good model without using copyright material. So these days, they try to increase the contract with these important and relevant information provider, like a New York Times, Getty Images. By making contract, they get a license to use those data. Okay, so then let's directly go to the machine learning setting. It's quite debatable, but I just grabbed one setting from the last year's challenge held by Google and Kaggle. So say we have a traditional training set, and we got a pre-trained model. I often call that as theta O, and then just as a parameter set, but it also indicates the model. And say we have a forecast set, it's DF. And typically our goal is to build a learning algorithm. And then after running that algorithm, we got an unlearning model, theta U. And then now we need to evaluate. And that evaluation is very complicated in some sense. But at least in this one setting, say we got like a remaining data, retained data set, DR, which is all the data set except the forecast set. And let's think about counterfactual where we just train with those remaining data without using anything from the forecast data. And then how the gold standard model look like, and comparing these would be one option. But also, of course, how to compare these 2 also matters. Are we going to just measure the altitude distance between this gigantic a parameter space? Are we going to measure the downstream performance? Are we going to measure on the forget set performance or generalization bound? That's all complicated issue. So I just brought a couple of very general common metric. So of course, accuracy on the forecast set, we want to forget. So accuracy must be low. But some people always like accuracy, higher accuracy is better. So people created unlearning accuracy as 1 minus that value, so that higher value becomes better performance. Remaining accuracy, it's the accuracy on the retained data set. It must be very high, if that's a good model. Testing accuracy is always important for machine learning because that's basically generalization capability. And efficiency also matters because typically we work with a gigantic model. If the algorithm is so complicated that the efficiency is closer to the actual pre-training from the scratch, it's not going to work. The disclaimer is all these scores not necessarily correlate with gold standard performance. And one step further, it's very hard to define which one is gold standard. Say we are going to go back to the word of a math. What I learned from the word of math is there's always axiom and then a lot of theorem. Say, think about convexity, and I can define convexity is on some like a set definition, or I can define that on the function definition. And we know that those set definition and function definition of a convexity are equivalent in a way that epigraph of the f, if that's a convex set, then the function is convex as well. So if we assume one is our assumption, then we can prove all the other theorem as part of proof. That's the beauty of math world. Here, all these metrics, they all making sense, but they are not really kind of a theorem that if one gets improved, the other must be improved. That's not gonna happen, especially in a learning domain. So that's why it's pretty complicated. And let's also think about some general method, so fine-tuning, because what we are doing is a pre-trained model, using before doing fine-tuning before using it makes sense. So one option is fine-tune our backbone model on the remaining data, few epochs, or just fine-tune on the forget data but with a random label. Basically, try to increase the entropy so that we can get confused about forget data. Or we can also think about gradient ascent. Typically, we always try to minimize the loss function with stochastic gradient descent. What if we actually go to the negative gradient direction? And then there's also unlikelihood training, which is one of the seminal paper by Sean Malek, and Professor Kyung-Hyun Cho was also one of the authors. We can make this as some sort of a contrasted format between the likelihood and unlikelihood. So for the correct prediction, the true token, which is xt, we'd like to maximize the likelihood, whereas for the random token, we'd like to minimize the unlikelihood. So that unlikelihood training also works, or may be very useful for calibrating the LLM's output logic later. Influence on learning, I don't know whether this term is official, at least a couple of papers use it, but going back to the 2015 and 2016, we were a lot interested in how much black box the model is, and how to actually analyze for whatever black box model, how to measure the impact of training set on the final performance. And we can definitely use the likelihood and some sort of a variation of the likelihood. And in order to get it, we also compute some sort of Hessian. So theoretically, we need Hessian, and it's pretty much similar to the second order optimization method, like a Newton method. But everybody know computing the Hessian was extremely expensive. That's why it was not that really popular. But these days, people are able to approximate that in pretty cheap method, and I guess that can be another way. And also, this unlearning method can be also regularized, because many of the setting, our machine learning setting, we know that loss function and the regularization are necessary to prevent the overfitting. So L1 sparse unlearning, its L1 regularizer can be combined with whatever objective as well. So those are motivations and just a general setting, but still these are emerging area. So many people have a different insight about that. So far so good? Any question for the settings? Well, maybe there are many questions that I cannot answer because nobody have very clear idea that this is the goal that everybody should aim for. But feel free to give me any question or intervene if you have, or something is unclear. So far so good? Okay, so let's go to the first topic, and that's instance-wise unlearning. We began our journey in image domain, and we were trying to do what are we supposed to do for the machine learning at the very beginning, and at least we try to find some relevant like a discipline within the machine learning area, and we thought the continual learning was very expensive, very important, because the continual learning, it's always try to maintain the performance after like a retraining on the streaming data. And it's, while like people have a different categorization of a continual learning, we have a pretty well-defined instance incremental learning, class incremental learning, domain incremental learning. So we may use a similar definition for that. So we begin with instance-wise unlearning. And at the time, not many papers are there. So we basically build our own setup. And at the time, we try to make, like assume, pre-trained model is given as parameter or as a model checkpoint. And forget data set are available, but that's only small amount of data set are there. Which means we don't know what type of data are used for training, pre-training. That data is not accessible. That was our setting. And then we thought about like how to do this. And so like we thought about a couple different directions, but during the experiment, we were able to realize that, just accessing these DF, forget data set, is not enough. So we need to extract some of the data from the pre-trained model, but these pre-trained models are not necessarily generated models, so we were not easily able to synthesize the data. So what we did was we tried to augment this forget data set by using the adversarial method, like L2 project gradient descent. So within the epsilon bowl of the forget data set, what if we get a new data set that can do some sort of an adversarial perturbation? And also we got some observation that we should not touch a lot of parameters on this pre-trained model. It's very quickly degrade the performance. So how to try to understand some important weight? There can be many different methods. While many of them are sharing some sort of a similar nature, they are all related to the gradient information or the second order Hessian information, like a Fisher. And this time we used the MAS method, which were from the continual learning domain. So that's basically related to the norm. And And let's think about the setting. That was even hard to say which one is Oracle setting. And at least when we first built this topic, we were not able to come up with, let's actually try to make the goal as in a parameter level, let's make the unlearned model's parameter very close to the model trained scratch from the retained data set. We were not able to actually come up with that direction. So in this case, we thought Oracle setting would be, I'm going to maximize this minimize unlikely or unlearning loss on the forecast set, and also I'd like to improve on the retained data set. Of course, these two must be balanced by the trade-off parameter, but just in high level. But our setting assumption is the retained data set is not accessible, so we need a proxy objective, and we try to think about kind of a regularizer. And for the loss term, we think two different directions. One is the gradient offset. So basically, that's a negative direction of a cross entropy for the classification setting. And another is, it's pretty much a simple cross entropy setting, but I'm going to relabel the ground truth label class, hopefully into the class which is farthest from the ground truth, or random class. And then with our adversarial regularizer, we basically augment this data set with adversarial stuff, as given in the previous picture. So by using that, we augment this data set, and we try to classify correctly on those confusing data set, which often we're not able to correctly classify by small adversarial perturbation. So we hope that can work as a regularizer. And then we developed one more regularizer in a way that parameters should not change. Mostly or parameters should change only on some like important like weight parameters. So we want most of the parameter remains same, only small subset of parameter can be like a learnable. And then we like evaluated a lot. So while the scale of the data set was pretty small, and even if I say pre-trained model, it was just the scale of a ResNet with 18 layer or 50 layers. So we did a CFAR 10 with ResNet 18 and CFAR 100 ImageNet 1K like with ResNet 50. And like each column, the K value means how many like samples we try to, how many instances we try to erase. And then the first row means the performance of the forecast set, second row means performance of the retained set, and the third row means the performance of the test set. So first row, smaller is better, the other two rows, larger values are better. And the before is like just a pre-trained model as it is, so its performance must be nearly 100% on the like a training data set. And then the Oracle setting, because these models are relatively smaller models, building the Oracle was easy. So we actually emulate the Oracle as well. And negative gradient is, it's basically gradient ascent method, but many people call it differently. Some people call it negative gradient, some people call it gradient ascent, but they are essentially identical. And RAWP from the repeated adversarial weight perturbation method, that's from the adversarial domain. And the final two method, ADV, like that's adversarial regularizer only, and the IMP is, that's with MAS as well. So if you see the performance here, there's a quite interesting thing. So forget set in this, mostly the toy setting, I just call it toy setting because we are these days, 2024, we are dealing much larger models. In this toy setting, like the forgetting performance is pretty good. They're all like achieving close to zero, and that also means that we like train multiple epochs arriving at that point. And then the retained performance, the Oracle method is of course very high, and what we can observe is negative gradient really quickly damage the model. It's very interesting that just a few iterations of a negative gradient impact a lot to the entire model, especially for this small, like a vision foundation model like ResNet. And then the adversarial method performs better among those like a baseline method and adversarial with mass regularizer, so that we can only touch important factor that performs pretty well, and that was like generalizable on the test set as well. And then we also, previously we did this one with the gradient ascent, but I talked to you that there are another method that we can just use cross entropy loss, but with the random relabeling. Turns out that this case, all the performance gets much better, which means the negative update on the gradient really damaged the model, and if you think about that, it's an unbounded loss. So if you take the negative direction, opposite sign, it's an unbounded loss. So optimizing that with even smaller learning rate, that's very easily, quickly damage the model. Whereas random relabeling, that still we are minimizing the cross entropy loss. So it's basically, yeah, it's not at all unbounded, and the stability is pretty high. So we got a pretty good result on that. And then we also did some sort of a engineer instinct. Should we do this with a mini batch? So, and also the unlearning setting, let's think about which should be the realistic setting. It's going to be very unrealistic that we access all the data to unlearn in a one shot. Typically we launch the model and we deploy the model in the real world, and some problems, copyright problem, contaminated issue, they just came out over time in a streaming fashion. So indeed, what is more realistic to us is unlearn several times in online manner or sequential manner. And at the time we call that as continual unlearning. In this setting, we are going to erase like from 8 to 128 random instances, but by dividing 8 as a mini batch. And it turns out that its mini batch is working pretty well. So while the impact on the image model and the language model, it turns out to be quite different. I will talk about that later. But if you think if you erase like 128 by ones versus like by 8, like if I give you general guidance, it seems to like sequential unlearning work much better. And if you aggregate that, even if you normalize the size of the gradient by the number of instances to erase, it's indeed like a damage much more. And we also try to, we also try to visualize the final layer of activations on the retain data set and forget data set. Turns out that the negative gradient really damages the decision boundary by t-SNE visualization, whereas if we use adversarial method, you can see that this forget set, which is described by triangle, and they all like remain there to allow us to maintain the decision boundary. So that was our finding on the image model, and the task was a classification task. So far so good? Any question? Feel free to intervene if you have any question. Interestingly, oh, go ahead.
Yeah, can you go back to the previous slide? I have one question.
This slide?
Yeah, because I think in real world, the input distribution is mixed domain. Have you considered that problem?
Oh, we have that. We have considered that with the language model. Yeah. And these days, if you go back to the ICLR submission last year, there are a lot of unlearning paper. And one thing that I remember, which was very seminal, is called the saliency-based unlearning. That's a SAL, which was an acronym of the model. I highly recommend to read that. That's actually working with image foundation model. And also there are unlearning on the image editing with diffusion model or diffusion with the transformer as well. Those are all very interesting progress. Indeed, while this paper got published in 2024, as I said, this was initially brainstormed 2021 winter. And in 2022, we finally did the work and submitted, but many people were not able to understand the setting. Why this setting, how to justify this setting, and what are the real world use cases which are aligned with this problem setting. And that was the most difficult part to convince the reviewers, and it got actually rejected a couple times. And that makes some a coincidence that indeed this sequence unlearning, which is on the language model, this work published earlier in 2023, but this work is actually inspired by the previous work. But the citation is basically reversed because of that, which is very unfortunate, but let's see that. Motivations. It's very easy to justify the motivation on this setting because now we are dealing with the LLM. Okay, I guess, for 40, now people get a little bit sleepy. So let's talk a little bit about my job in company. Of course, I have many jobs like our principal investigator. Of course, I'm not that amazing enough like Professor Yu, but we are doing research and sometimes make a publication. But at the same time, all these AI models, what I learned from the company is, say we publish a paper demonstrating SOTA performance, state-of-the-art performance, but it always fails on the real data. That's always there, and how to make this actually working for the real data. In many cases, many of the features are missed and not observed regularly, or the prediction time, it's way far from the data collection time. Or it worked with this very small set of tests, but in the wild it's largely broken. So those make our life very hard in one axis, and the other axis is the limited resource. I know this is a little bit contradicting that I'm working in a company and resources, of course, much larger than in typical academic setting. But think of it, see this. We train LM from the scratch after sanitizing the training data. That takes 900 A100 GPU. For not one day, it's like a couple weeks. That's tremendous. These days we are using 512 H100 GPUs to train our LLM, which is more than that computing power, but it takes a month. So always the frustration is, I'm scientist, or while I try to define myself more as an engineer. As a scientist, I need sufficient amount of experiment, but that's always impossible. So I do really minimal like a set of tests and then just release the model, and that in the deployment that always broke. So that's the hardest thing. How to realize AI in the real field is non-trivial. And another aspect, it's not just the data pre-processing, but differential privacy. Anybody who are interested in differential privacy? Recall that 2 years ago, Urip's best paper was actually new algorithm, DP stochastic gradient descent. Turns out that that's not really cheap, but that's actually claimed that that's like 1,000 times faster than the previous universal DP algorithm. So differential privacy, I'm not going to talk about that much, but that's another really big domain, and it's a useful formulation to quantify the privacy issue. And another thing is, let's say, just to perform few token update in our setting. So that's really comparing to retraining, it's working. So it's easy to justify in that case, and we use some sort of a sensitive information, either personal info or some even corporational level info. And the method was so simple. What is that? That unlearning objective is simply negative. It's next token prediction. So it's nothing but that. Yeah. It's LLM pre-training objective. It's not an instruction tuning objective because the loss never really goes through the prompt in the instruction tuning stage. So this is actually just the reverse of the pre-training on this sensitive data. So that's, in other words, gradient ascent method. And how to measure the performance? And maybe you guys get frustrated in this slide because all the metrics are entirely changed from the previous work. I talked to you that this work was inspired from the previous work, and one of the co-author overlapping between the two work, but the metrics are totally different. So like something like MIA, which is membership inference attack, I'm not going to talk much about that because that's a DP metric and we didn't really measure it. Whereas privacy risk, we try to say that like how likely we extract these sensitive information given prompts, or how well the model memorized these. So we developed EL, extraction likelihood, and we like reuse MA from the previous literature. So if I just briefly explain about this metric, the overlapping AB means A is a source and B is a target, and in this source, like a sequence with let's say n-gram given like hyperparameter n, we can make n-gram, n consecutive words or subtokens, and how many of them are actually appearing on the target B. So that's overlapping ratio. Then assuming that's the overlap function, then we can like compute that. Given n, hyperparameter n, we can just sweep through first token to the last token, and then how much are overlapping between the info that we'd love to forget, we need to forget, versus what model LLM predict. So that's basically average extraction likelihood by changing the length of the prompt. So that's EL. And then memorization is simply how likely this sequence of the token, the sensitive information, whose length is a capital T, and then how likely the model exactly predict that. So that's memorization accuracy. And then one interesting thing that we did, while it was almost a trivial thing, but nobody really tries, is how to define info got forgotten. That's another non-trivial stuff. So we define that if for that X, bold-faced X means a sensitive information or sensitive sequence of a token to forget. If EL, it's a lower than or equal to this average a sentence on the data set. Or, and at the same time, if this memorization accuracy is also lower than the average, like a sentence in the this data set. And by getting that, we were able to figure it out. There's some sort of a threshold to say that given this model, threshold would be this amount to say that at least we are at the stage of unlearning. And even if this work mostly done in 2022, and we did indeed use pretty small model, so it's mostly GPT-2 based model and GPT-2 Neo with the 3 different sizes, 125 million up to 2.7 billion model. And there were, at the time, OBT also got introduced from Meta. And then one of the benefits is it removed all the deduplicated info from the pile data set, which used to be the official data set for pre-training, the open language model like a GPT-2, GPT-J series. And then we believe if something got deduplicated, which is basically after doing some sort of a fuzzy matching, we remove something like repeating stuff. And then this, we believe that OBT must have a better performance on these tasks. And then the DPD plus is basically differential privacy based decoding algorithm. It's not really like a DP full training, retraining of the model, because as I briefly mentioned on the introductory slide, it's prohibitively expensive. And then this UL is Unlearning, that's our method, but unlike this gradient ascent method, and we did until we get the better performance than OBT. And then UL plus is we just keep running that until we arrive at the forgetting threshold. So we did 11 epoch or 13 epochs, but these forget data set is very small, so multiple epochs are not really costful. And we can see that it's our extraction likelihood or the memorization accuracy are not really state of the art. But if you see that LM performance, so we evaluated 2 different things. One is LM the accuracy as a classification performance. So did 9 different tasks and average that. And also we did 3 different dialogue tasks and measured, that's a generation task, but measure as an F1 score. So we see this downstream task performance. And if you see that, the DPD plus algorithm performs really well. That's really good, especially it controls the decoding, so it got the perfect accuracy on this exact likelihood. Whereas it quickly removed the language modeling performance. So basically it didn't generate anything making sense. Whereas our algorithm performs relatively better and also maintaining this language modeling performance both in classification and generation setting. So that was our observation. Oh, somehow the figure got lower resolution version appeared. But I guess it's easy to explain. We did this batch unlearning, tries to remove these 32 sequence at once versus sequential learning that we erased up to 128 by the batch of 32. Turns out that in language modeling setting with this gradient ascent types of an objective function, the sequential learning is much better. So the sequential learning, it's maintained the performance. The variance is a smaller model, it has a relatively large variance, whereas the larger model has a small variance and it can retain this average classification and the generation performance. turns out that the sequential unlearning, which basically aligned with the real world use case, worked well. We also test a per downstream task performance, and we just make 10 random samples, and we do this 10 runs with the unlearning with a single sample, not 10 samples. And if you can see that different sample has really different performance even on the downstream task. So that's very hard to predict. And another thing that we tried is a domain, a per domain performance. So we grabbed the 8 different domain on the pre-trained model, and actually grab 1 samples from each of the domain and try to unlearn 8 samples at once. And then if we see that some domain, the performance get degraded by a lot, whereas the other domain, it's actually pretty okay. Very small degrading is there. What we concluded there was if some domains like a code or emails, it has more structures. So if we just unlearn just random sample, it didn't really degrade much. So there's some sort of structure task degraded less. That was our observation. But personally, I don't think this is easily generalizable, especially with the new models coming these years. So that was our sequential unlearning paper, mostly on the text domain. We did both classification and generation. Any question? I guess I have only 10 minutes, so let me quickly go to the final topics. And then after doing this, we got a lot of frustration. It's still hard to know which should be the goal of the unlearning. And the LLM unlearning is, of course, non-trivial amount of a cost. And the objective function gets easily unbounded. So we have a lot of problems. And actually, when we do this tuning, the realistic setting, we cannot really touch. The full fine-tuning is very expensive, even if that's a fine-tuning. So how to do the more realistic fine-tuning, which is something related to the LoRa. So we basically get inspired by these 2 aspects, and what we build is some sort of a new objective for unlearning, and the way, a new option to initialize, which is beyond the LoRa. So those 2 are the main takeaway. So we try to tackle the unnecessary forgetting and unbounded loss, and then we want to extract just the important parameter in the perspective of DF for getting data set. So those 2 are novelty component. So we build that inverse hinge loss objective, and by the name suggests it's a differentiable objective, and the gradient can be computed by 3 different cases. But just intuitively speaking, we try to maximize the probability of the true. We try to minimize, because we're going to minimize the loss, the probability of true token, which are sensitive information. But there is some sort of a regularization effect by that max function, which basically accepted that true token, which should be the second most likely word, and comparing to that, we try to decrease the probability of the true token. So it always has some sort of a ruler that we cannot really unboundedly decrease the probability of the true token. And by doing that, we were able to just focus on small number of target tokens, because every time we got basically max operations there, then we just focused on V star, which is argmax stuff. So we were able to mitigate the gradient spread just to the XT, true token, and the V star, which is a competitor. And now the bounded loss can be changed into the unbounded loss into a bounded loss. And by doing that, we were able to preserve the generated performance, because if you see this gradient magnitude, the coefficient, that's actually proportional to the importance of that update. we will also design this feature-weighted initialization of low-rank adaptation. The way that we did it is, it's an a priori initialization of the network. So rather than just solving like a simple low-rank matrix factorization, which is W minus PA, it's a weighted version. And that weight is computed by the Fisher information matrix, and especially as a relative manner. So we try to, like, this value will be large if the Fisher information is large on the foreguess set relative to the retained set. So by doing that, we can only remake this LoRa update focused on some small number of low-rank parameters important for the foreguess set. So that turns out to be impact a lot. And then we did basically the same experiment with the previous knowledge unlearning setting, which may not be that super exciting or the realistic scenario, but at least as a comparable performance, if you see that, GA, gradient ascent, was the previous SOTA, whereas we also compare the GD method, which basically the gradient difference method. So that is the setting where we were able to access the retained data set by a small amount. So the objective function looked like that, and our setting is IHL only, or the LoRa initialization with IHL, or LoRa with this Fisher information weighted version and IHL. So we basically did all these experiments. The fundamental difference here is we were able to access small amount of a retained data set in this setting. So GD are our a direct competitor in that, because GD was the state-of-the-art method that requires retained set, small access to the retained set. We basically did it. And just in a nutshell, there are a lot of improvement. And if we can compare the perplexity of the language model, which is basically the pre-training performance measure, perplexity is also pretty retained comparing to the gradient ascent method or gradient difference method. But indeed, if we go to the larger model, the perplexity itself is very low, so it's not always get improved by using our method. But in realistic setting or the real example, that performs pretty well. And then we try to do a little bit more, because all this setting were a little bit artificial still in the sense of company. So how to actually do the real world test. And at the time, one of my friends published seminal paper, which is tofu paper. Anybody know tofu? He's very good at making a name, and very fun guy. Zach Chase Lipton in CMU. Still, I guess if LLM can say like him, then it's gonna be amazing performance. All the conversation were so humorous and sarcastic, so it's kind of the real data provider for LLM. Anyway, don't talk too much about Zach. And so this data set was very interesting setting. So given pre-trained model, he basically created some artificial, a person. Synthesized some person who never existed in the history, and also synthesized his work. This artificial guided blah 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 work, a piece of information or knowledge. And then fine-tune pre-trained model on that artificial setting, and try to forget that info. And that was very clever experimental design in a way that artificial data has never been existing in the history, so that's not going to overlap anything with other stuff, which allows us to measure the isolated performance, which was very clever. And then pre-trained model is there, so in some sense, we can directly compare to the Oracle, because Oracle is already there. So this is very clever setting. And then foreguess set, retain set, and also he prepares some real authors like C.S. Lewis. How many people read Narnia? Chronicles of Narnia? Which was one of my favorite, yeah. So C.S. Lewis and the world level fact, very simple fact as well. So almost final slide. A lot of sub figures. Basically, we compare our models to this gradient difference, our direct competitor, and just a case where we just use IHL inverse hinge loss, or GD with like visual information, like a weighted initialization, finally our like model. And here, because the pre-trained model is just by accessible by definition, this star is the like our goal measured by this model utility and like a forget quality. So this is 1% forget, 5% forget, 10% forget case. So reaching at this star position from the pre-trained, which is a black square, is our goal. Getting closer to the star is better, and we can see that this IHL plus, like with FILA, is indeed getting closer to that. But in some cases, if we need to forget a lot, we also need to touch quite a lot of parameter because it's now rank 8. So, or rank 8 may not be enough. So we need to touch actually quite a lot of parameter to get a really satisfactory Oracle level of performance. And we did it also for the Llama 2 7B, which used to be like many model line, the kind of important baseline. Now we have a Llama 3, like 3.2 as well. But at the time of the research, it was one of the like a prevalent model to use for academic setting. And the Llama 2, like some cases, we need like a little bit more training, whereas still it indeed performed pretty well. And for this Llama 2 setting, we also compare with like a preference-based alignment method like DPO or its variation NPO. It turns out that while it was not included in this slide, performed much better than those alignment method as well. Okay, so almost final. Still, there are a lot of questions, even if I introduced 3 different kinds of work. It's very hard to say that what would be the goals of unlearning. Say, I grabbed this book 3, which was part of the pre-training data set, and we used that for the second work, Knowledge Unlearning. So HarperCollins is one of the pretty famous publisher. I have a couple of books. And indeed, I also had an experience of making contract with HarperCollins to use their book as a data set, like a 7-year contract by paying like $5,000, like blah, blah. And then somehow a language model able to like print out its exact address, like Fulham Palace Road, London, blah, 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 with like a UK zip code system. And before unlearning, it basically shows like that, almost similar to the original text, whereas after unlearning, that actually substituted into Bloomsbury publisher, 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 kind of a repeating. If you actually in the industry, how to control the repeating penalty is also very important for the real users. So it may be byproduct of not sufficiently like a large repeating penalty. Anyway, it's hard to imagine what would be the ideal output. If we unlearn the info, what are we supposed to do? That same thing happens for the image domain as well. It may be easy to like generalize or visualize. Say there are some like sensitive info in this book. I don't know what it is, but let's assume that. So then what would be the ideal output? Like that's very difficult to imagine, I guess, even in that like image editing or the generated image setting, image generation setting. So the goals are, even in this high level, that's very unclear. Lots of questions remain. Like sometimes sequences may be given, but say, oh, I want to forget everything about Harry Potter, because Harry Potter books are the copyright information. Then, say if somebody asks about Hermione, then should we like skip everything about Harry Potter, or are we able to talk about Hermione without talking to Harry Potter? Is that possible? It's very difficult questions, and there turns out to be actually Harry Potter work for the unlearning domain. And knowledge or domain, even multimodal unlearning, that's nobody, like a multimodal unlearning, I've never seen any work. And what would be defined as a success? Forgetting or permanent removal And what is permanent removal, by the way? That's also pretty complicated. Definition of a gold standard should be approached to the parameter level. But think about it, all these, like a deep learning model, are extremely good at interpolation, because that's why we learned large capacity with continuous representation, and all these models are differentiable. Basically, the models are designed to do well for the interpolation. Say there's a model that automatically screens your resume in the company. And sensitive information may be gender information, because a lot of company, historically, the males are dominant on the company hiring scene. If we use historical data as a training data, no matter how large model, it's easily to do the shortcut learning, just to gender and classify with very high performance. Say I erase all the gender info from your resume, but the models are so good at interpolating gender information by seeing your hobby or whatever, your history of. It's so easy to see that. And that's also related to what is the permanent removal and how to evaluate, or practically when to stop unlearning. I see a couple of cases that our a feature weighted information, initialization, that is excessive unlearning. It's very hard to know when to stop and what would be the ideal output. So it's a pretty much underdefined area, whereas its implication to the society or even the industry level, contamination issue, privacy issue, the copyright issue, the implication as a cost are tremendous. So it's interesting as a machine learning, or if you are a theoretical researcher, stochastic gradient descent is itself very interesting thing, and how to work that with a saddle point method, things like that. Those are all maybe we can navigate with different loss function. But high level or the societal, a lot of things are underdeveloped. So hopefully many people get a little bit of inspiration from this talk. That's pretty much all. Thanks for listening. Any question? Feel free, or it's beyond the unlearning domain, it's generally fine. Or if you're interested in LG, AI research, you can also ask that. Unless it's really sensitive information, I cannot really unlearn easily as a human. Yeah.
So, I have a question. I guess I haven't really thought about this problem in depth. But let's say you had a model that learned everything, and then you also had a model that didn't learn. So you excluded all the information that you thought that needed to be forgotten. Okay, so you had two models. One model you threw away, made it learn everything, and then the other model you looked at the data and excluded all the information perfectly. And then you applied, the other model that learned everything. You wanted to apply this forgetting algorithm. Compare. How would you? So I guess if you apply this algorithm, the algorithm that you mentioned, it will forget things that you wanted to forget, but it's going to forget other things. That's what you're trying to say.
Yeah, so you're right. So our goal is to selectively forget the information that we just need to forget. But that's very hard to define, not just because of the algorithmic nature. Say, I forget something, whether I actually really permanently forget it or not, it's hard to decide. And This is selectively forgetting, but without forgetting the others. So there may be intrinsic collision that by not forgetting things which should be retained, it might reconstruct the things to forget. That's the like a contradicting nature of permanent forgetting, I guess. And how to evaluate, cause say I need to forget a lot about Harry Potter. I remove everything about Harry Potter from the data set, retrain the model. But that model may know quite well about Harry Potter by like jumbling or stitching some of the piece of information because it's a gigantic model. If we see the amazing performance of ChatGPT, it's not going to be surprising to see that. So what would be actually ideal things to compare in that case? And the flip side of that question is what is a permanent removal of the things that needs to be forgotten? These are like, somebody can even argue to the philosophical level, and that's, yeah, very interesting question to me. And that's why I did a little bit of work, not my mainstream work, but yeah.
So, I think it sort of relates to, it's difficult to have a model forget certain things because it may also relate with other stuff. So maybe you just tell it to not produce the results on the stuff that you wanted to forget. No?
That could be one option, and that's a typical resolution for the safety research. So while I'm not underestimating we, like AI scientists or computer scientists, it's the way that we align the model. Of course, we try to like align the model which is more like agreeable to the human user preference, but whenever this like complicated or sensitive questions are given, we try to make the model just avoid the answer. And that's also quite debatable whether that's the right direction to go. Yeah, simply just like denying the answer would be the right direction to go. At least one of the new algorithm called the safety pill we just published, and that's our goal is try to answer at least usefully safe rather than simply just avoiding the answer. But that's very hard thing. And avoiding the answer eases the solution to get or to avoid the legal cases. But that's not, nobody knows actually, I guess. Go ahead.
Thanks for the talk. And I have a question about after unlearning, is there any issue if we engineer the prompt, it can somehow generate the unlearned knowledge?
So while our metric would not be really like convincing for every different cases, so we try to measure the exact likelihood and the memorization accuracy. If that's low, as I demonstrated by this qualitative example, it's basically produce something really awkward instead of the sensitive information. That was reasonably successful based on our probing of the model. But of course, there can be many different prompt variations. So in certain prompt variation, it might still elicit the sensitive information. That's hard to prove because we cannot really try everything.
Okay, so that was a really wonderful and thought-provoking talk. Just like to thank our speaker today for making this travel and sharing this wonderful topic with us. And hopefully, maybe we can send you an email if we have if we think of something. What we did. Okay, let's thank the speaker again once more, and let's